9.1, Example 3. Before we dive into Example 3, I first want to talk about how to identify divergent series from convergent series. So if we have an infinite series, which is defined as sigma from k equals 1 to infinity of a sub k, which would be equal to a sub 1 plus a sub 2 plus a sub 3 all the way to a sub k, adding all the terms together, converges, then that means the limit as k goes to infinity of a sub k equals 0. And what that means is when you get to that final term, and if you let k approach infinity, you better get 0, which means you're adding on 0 over and over and over again. Because if you're not adding 0, 0 over and over again, then you're going to be adding something to that sum, and it's going to either get larger or more negative. So one really important thing to note is that if you get the limit equals 0, that does not necessarily mean that the sequence will converge. If it converges, then the limit will equal 0. So it matters the order. If you have the fact that it converges, then you get it equals 0. If it equals 0, that does not mean that it's going to converge. So again, if a series converges, then that means that the limit of a sub k as k goes to infinity will equal 0. However, if the limit equals 0, that does not always imply that the series converges. So it's really important that we remember that. However, something we can take away is that if the limit does not equal 0, then the series must diverge. So if the limit does not equal 0, so equals a number, then the series must diverge. Okay, now let's get into the definition of a geometric series. So let's first talk about how you make a geometric series. You're going to have some terms, a sub 1, a sub 2, a sub 3, and so on. And the term number 1 is just a. The term number 2 is the first term a, so a sub 1 times r. The third term is going to be a times r squared. The fourth term, a times r to the third power. And the nth term is a times r to the n minus 1. Notice that the power of r is always 1 less than the term, and we write that like this. Sigma from n equals 1 to infinity, a sub 1, or just a, times r to the n minus 1. Now a series will converge to the sum a sub 1 divided by 1 minus r if the absolute value of r is less than 1. And this means that r is between -1 and 1. Not equal to, but between. And we call this the interval of convergence, or the radius of convergence. And it will diverge if the absolute value of r is greater than or equal to 1. So if we can identify a geometric series and write it like this, or at least identify r, we can determine really fast if a series will converge or diverge. So leading into example 3, we're going to go ahead and determine if this series converges or diverges. And if it converges, I want to know what it converges to. So the first step is to identify r, and we can see really fast that r is 1/2, which is between -1 and 1, so therefore it will converge. If you're not sure, if it doesn't give you this exactly, you can start writing out terms. And this is going to come in handy later, so I'm going to go ahead and show you how to write out the terms. So since n starts at 1, the first thing we do is go ahead and plug in 1. So it's 3 times 1/2 to the 1 minus 1. This is the first term, plus 3 times 1/2 to the 2 minus 1. It's my second term, plus 3 times 1/2 to the 3 minus 1, and this is my third term, and you just keep doing that forever. So if I go ahead and work that out, I get this is 3 times 1/2 to the 0 power, plus 3 times 1/2, plus 3 times 1/2 squared. And you can see that the pattern here is that it's a times r. So here, these 1/2 is my r, and this 3 is my a. So I get a is 3, and r is equal to 1/2. So since the absolute value of 1/2 is less than 1, the series converges. So now in order to find out what it converges to, we're going to go ahead and plug in everything into that formula. So the formula is a sub 1 divided by 1 minus r, and a sub 1 is 3 divided by 1 minus 1 half, which is going to be 3 minus 1 half, which is 6. So if you were to keep adding up these terms over and over and over again, you would get 6. So we write that as sigma n equals 1 to infinity, 3 1 half to the n minus 1 is equal to 6. So when you're given it in the form of sigma, it's pretty straightforward and pretty easy to determine. Now we're going to look at it when it's given as a sequence. So again, what you need to do is determine the first term. So a sub 1 is going to be 1. And we need to determine r. Now I know this is a geometric series, and it's really easy when you have the last term written out. It's right here. That is r. If you don't have that, you notice what you have to multiply by to get from one term to the next. So times r. And we can see r is negative 1 half. So then the absolute value of negative 1 half is less than 1. Therefore, it converges. And in order to find out what the sum is, we draw that s with the fancy symbols. And it's going to be a sub 1 over 1 minus r. So a sub 1 was 1. 1 minus negative 1 half. So I get 1 over 3 halves. So it's 2/3. So this series, if I keep adding it up over and over and over again, following the pattern, will eventually just get 2/3. Okay, for part C, we need to identify a sub 1 and r. So the first thing I'm going to do is write a couple terms out. So I get 3/5 to the 0 plus 3/5 to the 1 plus 3/5 squared, and so on. So I can see that my r each time is going to be 3/5. And a sub 1 is the first term here. So this is a sub 1. So a sub 1 is 1, because 3/5 to the 0 power is 1. So the first step is to determine if it converges or diverges. So you take the absolute value of r, and it turns out that is less than 1. Therefore, this series is going to converge eventually. And to find the sum, we're going to go ahead and use that formula a sub 1 over 1 minus r. So it's 1 over 1 minus 3/5, which is 1 over 2/5, which is going to be 5 halves. All right, so we have pi over 2, pi squared over 4, pi cubed over 8, and pi to the 4th over 16. First step, identify that first term. It's going to be pi over 2. The next step is we have to identify r. Now I know this is going to be geometric, so I can divide two of the terms. So to find r, I can go pi squared over 4 divided by pi over 2, which is going to give me pi squared over 4 times 2 over pi, which gives me pi over 2, which is approximately 1.57 something something something. So then pi over 2 is greater than 1, therefore this is going to diverge. And we don't even have to use the formula because it diverges. Another way you could have done this is written this as pi over 2 plus pi over 2 squared plus pi over 2 cubed plus dot dot dot, and you can see that r is pi over 2 every time. So again, if you get r is larger than 1, it diverges. If it's less than 1, then it's going to converge, and you have to use that formula. Okay, so on your own, I want you to give this one a try. I want you to determine if it converges or diverges, and if it converges, tell me what it converges to. Alright, so let's give it a go. So for part A, my first term, a sub 1, is just 1, which I get just from that first term. And I can see that r is the thing inside of the power every time. So I get r is 2 over 3. So then I need to make sure that the absolute value of 2/3 is less than 1, which it is, which implies that my function is going to converge. So then I just have to use my equation. So I get a sub 1 divided by 1 minus r. So I get 1 over 1 minus 2/3, 1 divided by 1/3, which is 3, which means my series will eventually converge to 3. All right, let's go ahead and try the next one. So for the next one, I have 1, -2, 3, -4, 5, and etc. So I'm not really sure if that's going to converge or not. I don't really know what R is. Well, I know it's not geometric. So let's start just writing out some of the sums. So the first partial sum is 1. The second partial sum is 1 minus 2, which is -1. The third partial sum is 1 minus 2 plus 3, which is 2. The fourth partial sum is 1 minus 2 plus 3 minus 4, which is -2. So it looks like the numbers are getting larger, which is not good. But that also implies that this thing is going to diverge. So I don't need to find the sum because it ends up diverging.